We, Team Latency Zero present here, a malarial disease detection project using tiny machine learning. Economic cost of the infectious diseases like HIV, AIDS, and malaria are significant, and their increase in total productivity owing to death and reduced profitability and decreased foreign investment has had a serious effect on the economic growth. Actually, malaria is a disease that transmitted from person to person by infected Anopheles female mosquito that transmit a parasite that enters the blood system and travels into the person's liver where the parasite reproduces. According to WHO's latest World Malaria Report, there we are estimated 241 million malaria cases and 6 lakh plus malaria deaths worldwide in 2020. We mainly focus on two major solutions. First is testing the blood sample and detect whether the area is affected by mosquito. Initially, we check whether the area is affected by mosquitoes using our sound detecting hardware. If the presence of the Anopheles mosquito is high, take the blood sample of the people in that locality and check whether they are affected or not. Then ask them to consult a doctor for further steps.
Thank you, Fasna. Now I am describing our first project, that is malaria detection using open microscope. Here we are, this is first step, that is data acquisition. Here we are uploading our files, that is we are uploading two files, that is named infected and non-infected types to train our model. We are uploading in such a way that in fact 80% is gone for training purpose and 20% is gone for 20% is gone for testing purpose. You can see the data over here. Now that is impulse design. Impulse design, we are using image data learning block as well as processing block we are giving. For example, the purpose of image data is to resizing the images uploaded are in various size, so we are resizing the image. The processing block, it is used for processing process. Learning block, there are different types of learning model in machine learning, so we are giving corresponding recommended model to the to train the machine. Now we are this image is used for which whether the image should be RGB or grayscale. We are using grayscale because for more accuracy, and then we are finally trained the model and we get an accuracy of 94.6%. This is our trained model. This is the graph of our trained model. Since the lack of availability of hardware, we are doing a live classification. This is provided by this platform, so we can check whether our trained model is work or not. For example, I am collecting an infected image of the RBC and I am loading the sample. I am giving input to the sample, and it is shown that it is shown our training models are seen that it is infected, means giving an accuracy of 0.96%, 0.96 or 96%. This is the hardware part of our project one, that is malaria detecting using open flexure microscope. Here we are using an open source open flexure microscope. Its development and implementation as well as 3D printing are all given in the download link. We are using the development board, that is Jetson Nano, for training our model, which is given in below. The sample is taken from National Library of Medicine, Mr. Hill National Center for Biomedical Communications. Since we are not implementing hardware as we didn't have hardware, we have done it in Edge Impulse platform. Hello guys, welcome back, and now I am going to explain our second project, that is classification of mosquito based on their voices. Here we are upload a sample. I upload in two label: malaria mosquito, that is Anopheles mosquito, their sound is uploaded, and as well as mosquito of other sounds of other mosquito is uploaded in the form of other mosquitoes, and we are creating impulse design, which is very similar compared to that of our first design. Since due to lack of our hardware, we are using the window of the our platform for testing our training model. So I'm loading the sample of a malaria mosquito sound. Then we get an output, that is out of 24 questions done, almost 24 are detected as the sound of the malaria mosquito. I'm showing our trained model, which has a frequency of 100% accuracy. This is our trained model. Now we are going to deployment. We can deploy it in any other library or board. We are deploying in Jetson Nano, which is our first project is also deployed on Jetson Nano hardware. Okay, we can by clicking here and just building, we get the code for the hardware code, and we can easily deploy it into the hardware. Okay.
In project 2, the steps are very similar to the project 1. So we are using PDM microphone to detect the mosquito sound. The concept of our project is that presence of mosquitoes in a particular area can be detected and appropriate control measures can be taken against the diseases transmitted by them, thereby testing the individuals in the area to reduce the spread of their diseases. And it is doubtful what is important of controlling such diseases in the concepts of COVID epidemic, but many deaths are still reported in India and other foreign countries. So we believe that our project is relevant.